Morning and welcome to our webinar on building a machine learning fraud model. Really excited to talk about this topic. I believe we have around 800 people from all over the world signed in, so really excited to talk about this with all of you, wherever you are kind of dialing in from. This is a topic which a number of our customers, when we're on the road, ask us about, and so we thought we'll put some content together. Working with one of our customers out here in Seattle from Momentum Travel. Before diving in some housekeeping items, first of all, the entire webinar will be recorded, and you'll get a kind of a link to kind of view it. And you can share it with other folks in your organization who probably couldn't join this webinar. Secondly, we'd love to hear your questions. There should be a question and answer box in your console, which you can use to send in questions. We'll try to field as many questions as we can at the end. And for the ones we don't have time for, we'll definitely reach out to you after the webinar with our thoughts on that. So let's get started. A quick overview of what we'll be talking about. Dustin and I will be taking turns. I'll kick the webinar off, giving you a little context about Whitepages Pro, some of our products we've built using machine learning, and how we work with our customers who want to use our data in a machine learning model. Then I'll hand the baton over to Dustin, who'll talk really about how they went through the entire life cycle of from deciding to build a machine learning model, implementing it, and then iterating on it. You must be wondering who we are, so some quick background. My name is Ajay. I run product management for Whitepages Pro, which is our B2B SaaS business at Whitepages. I have a team that spans product management, user experience, and data science, and we build a kind of a suite of global identity verification products. And our focus kind of verticals span from e-commerce, online lending, kind of marketplaces and the sharing economy, as well as increasingly payment processors. Dustin, do you want to tell folks on the line a little bit about yourself and Momentum Travel?
Yeah, hi everybody. So we'll get into it a little bit more as we get into the slides here, but I'm Dustin McDonald. I'm the Director of Fraud Prevention for Momentum Travel Group, online travel agency specializing in flights. I lead the fraud program here, including data science, analytics, and operations, as well as engineering, and excited to tell you more about our journey.
Awesome. Thanks, Dustin. So moving on into Whitepages Pro. For those of you who are not familiar with what we do, our entire product strategy is premised on focusing on kind of a very limited set of attributes: email, phone, address, name, businesses, and IP address. And we believe that we can use these elements and build a number of linkages and risk attributes that we use to verify the identity of a customer in a kind of a range of workflows. The way we think about it is that we have kind of two broad categories of products. At what's called the top of the waterfall, in most kind of companies, there's a decisioning engine, which historically has been rules-based and increasingly is moving to machine learning. And that's where you can plug in a number of APIs we provide to really drive decisioning, on the lines of an accept, a reject, or a manual review. And in the case where the company does a manual review, we provide a web-based product called Pro Insight, which is really a visualization of our data to allow a human being to dive deeper and make a decision whether you should ship a good to a customer, should you kind of open an account, and so on. So that's the way we think about our kind of product spectrum. We have a number of products and attributes built using machine learning, but really our kind of confidence score is our marquee product. The training data we use to build this product leverages both our identity check response, which comprises of those attributes I spoke about earlier, which include linkages between phones, names, addresses, and IP, as well as metadata or risk attributes about the individual elements. So things like the line type of the phone, the email first seen date, the kind of proxy or riskiness of the IP address. And we kind of complement that with our kind of proprietary identity network, which really is trying to answer the question about, have you seen this kind of email, phone, IP, or kind of address historically? And if we have seen it, like how long ago did we see it and with what velocity? And we have found that to be really correlative with it being a good customer or a fraudulent customer. So our score is built kind of leveraging those attributes. It uses kind of an XGBoost ensemble model, and it can be used both in a rules-based system or thrown into a machine learning model. I want to spend just like a bit of time talking about what machine learning means at Whitepages Pro. It's a really exciting time for us. We have a small but growing team solving some really hard problems in the fraud space. Innovation spectrum ranges from the kind of the confidence score I spoke about, network attributes, which comprise the identity network, reason codes, or kind of like explainable risk attributes that we surface in our Pro Insight product, as well as a number of other projects which we're working on right now. We also power fraud detection for our sister B2C business called Whitepages Premium, primarily because we use that as kind of a place to dog food our models and kind of test out new solutions and really answer the question whether all our work actually makes a difference in a real world kind of setting or not. We leverage typically tree-based models, historically random forest, increasingly kind of XGBoost. And we're really moving fast in terms of innovation, while also measuring performance, typically using both statistical measures like kind of AUC, KS metrics, as well as complementing that with business metrics such as how many chargebacks are we kind of saving our customers, how many manual reviews are we reducing, and kind of condensing that into a net dollar number. And that's really the kind of framework we use to decide whether we should implement a new attribute or implement a new model or not. With that, I'm actually really excited to pass the reins over to Dustin, who's going to talk really about their experience building a machine learning model and kind of integrating our data. Over to you, Dustin.
Thanks, Sanjay. All right. So, yeah, as mentioned, I'm Dustin McDonald, working with Momentum Travel Group. A little bit more about the company. We're an online travel agency. We specialize in flights. We're headquartered out of Montreal, Quebec, in Canada. We've got two sites, justfly.com, which is our U.S. brand, and FlightHub in Canada. We're serving customers around the globe. Those are our two primary markets. A bit about our fraud team. So we're based here in Bellevue, Washington. We've got operations, data science, and analytics in-house here. We also have team members in Montreal and Gurgaon. So our engineering team is in Montreal. We've got an operations team in Gurgaon, India. And we're a 24/7 operation. So I'm excited to talk a little bit about our journey, just a bit of background. So I've been with the company for 2.5 years, and coming in, it was growing really rapidly, and the fraud product, the program was not scaling with the business. So it's really been my task over the past 2.5 years to build out a fraud team and process and modeling system that's scaled with the business. A bit about travel fraud for those who aren't familiar and some of the challenges. So a couple of things. It's completely digital delivery, right? So it's we're sending the tickets via email to our customers. As I mentioned, travel's happening 24 hours a day, 7 days a week, which has its challenges. And then specifically about the air agency model, it's fairly risky from a fraud perspective. We're working as an agent with the airlines. The margins are fairly low on selling tickets. We get a small commission for every ticket that we sell, but in the case that fraud happens, we're on the hook for the entire amount of the ticket if a fraud chargeback occurs. So we invest very heavily in preventing fraud up front, and that's why we're so focused on preventing chargebacks and building out this system to do that. The machine learning model, why we decided to go this direction, it's been more of a process than anything, right? So it started out with really rebuilding our operations, rebuilding our rule sets to be able to stem some of the fraud that we were seeing. But as we've grown and developed, machine learning has made more and more sense for us to be able to continue to scale the operation and do a better job of preventing fraud and allowing our good customers through and all of that great stuff. So we'll get to talk a bit more about the results here moving forward, but we'll tell you a bit about how we built the model, some of the pre-work that we did to get there, and I hope it's good information for you. So a few things in setting up to be able to build the model, a few keys to success, I'll call them. One is really making sure that you've got a strong manual review process in place. Obviously, with any model, it's only going to be as good as the data that you're training against, the data that you're putting into it. So the first step, as I mentioned, was really rebuilding our operation and making sure that what we're screening as fraud is actually fraud, and we're feeding good data back into our model. On top of that, as Yue, my data scientist, can attest to, is there's a lot of just cleaning, scouring through data, wrangling data, processing data to be able to be consumed by a model. So spent a lot of time just building that infrastructure so that we could use our data for modeling. On top of that, it's getting a deep understanding of your data, understanding the features that you're evaluating, and how that might be used in a model. And then kind of leading up to that, just getting a extremely clean data set where you're confident that what you tagged as fraud is accurate. And not just tagging as fraud, there's kind of several different resolutions that we have here. So really having clear and consistent fraud data tagging, so true fraud, card stolen, friendly fraud, more of the kind of service issues, and making sure that you vetted all of that out so that your data set is extremely clean and that you have a very targeted approach for what you're building your model against. And then obviously the most important part for me in building this model was hiring a great data scientist. I'm happy to introduce Yue Kai, who will tell you a little bit more about kind of the getting into the data and building the model itself.
Hello, this is Yue. Thanks, Dustin. I'm the data scientist here at Momentum Travel. I am responsible for our in-house machine learning model for fraud prevention, what we call FraudNet, and also name. So here I'm going to talk a little bit about our model building and testing process. So on the slide, you can see a very basic workflow of a offline model building. For some person who is not really experienced in machine learning, this will probably be the first thing you have to remember. This is a very basic structure when you build a machine learning model. So here are some things that you probably want to be very aware of when you're building a model. So especially for a fraud industry like us. So first of all, just as Dustin mentioned, you need to make sure your data integrity, especially the independent variable. So here, independent variable basically means what you're trying to predict, and in fraud industry, it's whether you want to pass or reject transaction, fraud or not. So especially for an industry like us, where we manually review part of our transactions, you will always have situations of people's mistakes that, for example, reject transaction that should not be rejected, label a friendly dispute as a chargeback fraud, which in the end you label a transaction to be what it is not supposed to be. And since machine learning model learns from all these label data, when the label data itself is wrong, you're going to let the model learn from bad things, which lead to a bad performance of the model. So these you need to make sure the first. Second is during the process, you really want to cross-validate on training set and test on an unseen data set. This is all offline, of course, but still, like, cross-validation means for your training data, you want to actually use every piece of the training data to test one piece out of those training data as what we call validate data. So this may sound a bit complicated to you guys, but this is a very basic concept in offline machine learning building, and you really want to make sure that so that you avoid like back and forth testing your models through performance. And the third, which I think is also a very, very important point, is you want to choose a proper matrix that match your KPI goals. So, well, maybe in academic world, when you build a machine learning model, what you really care about is only what we call accuracy, kind of, but we're in a business, right? We have chargeback we want to control the loss we have in chargebacks, control our number of manual reviews, because that's related to our operation costs. There's a lot of things to be considered. So you can't just track just accuracy. You want to take all your other KPI into consideration. So that you need to take care of. Okay, more about on the testing side. So here I'm testing. There are two parts of model testing, which are offline testing and online testing. Offline testing is when you build a model offline. You want to test it before you put into production its performance and its matrix. And there are two things which is very basic but also very important in terms of the machine learning model building in a fraud world, which are confusion matrix and ROC curve. You do know that in a lot of circumstances, accuracy really means nothing to a fraud industry. Just for example, you have 100 transactions in total, 96 good transactions, and 4 bad transactions. If my model just say, I don't even want to predict, I just say 100 of them are all good. Yeah, you get a 96% accuracy, but does it mean anything? I just say all of them are good. So accuracy means very little in terms of fraud work. So that is like where we really want to check the confusion matrix and the ROC curve. Confusion matrix, as you can see on the slide, is a matrix consists of true positive, false negative, false positive, and true negative. If you are, again, in fraud world, you have an understanding of this chart. I want to talk more about on the ROC curve. So ROC curve, which also you can see on the slide, is a relationship between true positive rate, false positive rate against every possible threshold you can set for your model. You do know that the model gives you a probability, but how we interpret our probability is on our hand. So this actually shows what exactly I just said. The true positive rate, false positive rate against every possible structure you can set. And another very important concept is the area under curve. Generally speaking, if you can see, the larger the area under your curve, which can be quantified, the better your model's performance. And this is a way better matrix than accuracy. Again, and also I want to mention more about this is a a matrix you want to track. But again, it's still just a matrix for your model. When you take your business into a model, you need to take your operation cost, your loss in fraud, and blah, blah, blah into that. And we can actually use some traditional statistics method, or you can be more creative on that to, quantify them and put all those features into the same kind of a formula, quantify your, what we can usually call unit net economic benefit. I won't go through very detailed on that, but just bear in mind that you don't want to only track one matrix on the model, but to put your business KPIs within that. And the next is online testing. So don't assume that when you test your model offline, everything is perfect. No, that's not in the real world. And A/B testing is actually a very, very big topic in all those big companies. They have dedicated teams with like maybe a dozen to hundreds of people just do A/B testing all the time to make sure their online service meets their presumptions. I won't go through a lot in A/B testing, but I just need to tell you this is really important. You have to do it when you after you push your production model to serve your customers. Several things I do want to mention is one that we call control groups. So for several companies, which their amounts for example, dollar amount for every transaction is low, and you have a plenty number of transactions, which you probably want to go through is a concept called control groups, which is very simple. You just expose your one sample group of transaction to any customers, including the process, which means you don't use any fraud prevention methodology on that. In that case, it will give you the best data you can have from your data's performance. But again, I understand it's not really available to any of the industry, any of your companies, even including us. So the second thing which I want to mention is building up the confidence. Even if you don't go through the control groups, you can always use your manual review method and afterward review method to try to assess your model's performance. But the important thing is you want to build up confidence gradually. Not only as maybe you are the data scientist, you are a data analyst, or you are the executive, but you want to go through the process. It's okay to be slow, but true to build up your confidence and tune your whatever model you have on hand to make sure it works properly. And so that you can have a good understanding of your model.
Yeah, so I just want to kind of reiterate a couple of points there. So in fraud, I think one of the big challenges is that when you're training a machine learning model, your target is a very small percentage of your sample, or at least hopefully it is, right? So I think UA has done a great job of exploring different sampling techniques to make sure that we have a good training data set and we're able to get the type of performance that we need from that very small target. So from kind of oversampling our chargebacks or overweighting some of our confirmed fraud to be able to get the results that we've seen. And also just going back to his point about how we assess the model to start with. Again, accuracy in this space, since the target is so low, if you were to predict everything is good, your accuracy would be great, but you would still be missing all of your chargebacks. So it's really important to understand how the model is behaving and performing before you launch it into production. And then, as he mentioned, just a bit more about how we launched the model. So we had done all this pre-work, created the model, and we did the A/B testing. So we started with a small percentage of our bookings being evaluated by the machine learning model, the rest of them on our legacy model, and monitored that on a daily basis. So we would go in and look at that sample of what was assessed by the model, look at where it was conflicting with the decisions on our previous model, and sitting in a room and going in and looking at them one by one to understand why the model was making the decisions that it was, and making sure that they were the correct decisions. And I think through that process as well, you get to learn a bit about where you might have missed in creating the model, if there were variables that you didn't consider or if there's other rules, business type rules that you need to put in place in front of it. For example, as we launched the model, it wasn't looking at the value of the ticket necessarily, right? So it was just trying to predict, is this fraud or is it not? From a business standpoint, we want to be extremely careful for those, $20,000 bookings. So we put a little bit more weight on the value of the ticket and manually reviewing more of those. So it was a really important process just to kind of fine tuning what we wanted to see from the model and making sure that we covered all of our bases in creating that. So I'll talk a bit about the results that we've seen. It's been really great so far. So I think a few things that we've already been able to realize after launching the model. A big one is the decrease in the review rate. And as I mentioned before, one of the main drivers of building this model was to create scalability. So as the business grows, we don't want to be adding agents at the same rate that the business is growing. The machine learning model is helping us be able to take on that additional volume without having to add additional resources to be able to handle that. So you can see on the graph on the right, just as a quick visual representation of how our review rate has been performing over the past several weeks. Seeing great results there, and I think as we continue to perfect our model and make sure that our training data is getting cleaner and cleaner, we expect to see that trend continuing to happen. On top of that, we're also seeing just better quality across all of our other metrics as well. So we have more accurate auto rejection occurring. So, looking at what we were auto rejecting before and after, we're seeing less false positives in that data. On top of that, our chargebacks were already in pretty good shape heading into this. We've been able to continue that performance and actually seeing some additional improvement there, which is fantastic to see as well. We've also used the results in some interesting ways operationally. So especially as we were just sampling the data, we were surfacing some manual review errors as well. So the model, for example, was showing a very, very low probability of fraud, but the agent was then canceling that booking through our old rules. We were able to get a sample there that we could get feedback back into our operations team to review, why are we canceling these incorrectly, and getting that feedback back to our team. And also just through reducing that review rate, we were in a place where we were really asking a lot from our manual review agents. We've been able to back off of that a bit, have them focusing more on accuracy and making the right tags on the data so that we can continue this process of improving our data, improving our modeling, and continuing to get better results for overall metrics. Since we are with White Pages here, I wanted to just do a quick shout out about the identity check score. As we were building the model and looking at variable importance, one of the kind of most important predictive variables that we were seeing was the identity check score that we had recently signed up with them to implement in our data. This, what I'm showing you right here, is a tool that Yue put together, kind of going back to his task of building confidence with the leadership team and how the model was making decisions. He created this tool to provide a bit more of a layman's explanation of why the model is making the decisions that it is. So this is just an example of one of our bookings. But as you can see, looking from the top to the bottom, it's listing out the variables that were considered in making the pass or fail decision. And as we reviewed these in the room, as I mentioned, when we were doing the A/B testing, we were sitting and looking at these bookings. The identity check score was surfaced, is sitting at the top of this rule set extremely often. So in this case, what this is saying is that the identity check score was only was the most important thing next to hot and warm list variables. So extremely valuable in the model of being able to make accurate decisions. And we're really happy with the results that we've seen there.
And that's just part of the rivals we have. After we call hot encoding, like literally hundreds of rivals in making the prediction. It's just this slide is too small. I can't fit all those rivals in there.
So a little bit about next steps, as I've hopefully hit on several times throughout this presentation. It's about continuous improvement at this point. The model is running in our system. It's making great decisions. To continue to see lift from that, we're working to improve the accuracy of the data that we're feeding back into it for retraining. So focusing on our operational process, cleaning our data, making sure that we're making the right decisions, and providing really great and clean data for retraining. And again, tagging the data in a way that's meaningful for us. On top of that, we're finding opportunities to develop new variables, either through a combination of the variables that we're already using. So, maybe looking at lead time plus dollar amount and creating a variable that way, or going out and sourcing new data through third-party providers like Whitepages to bring that into the model to continue to drive improvement in performance. And then also just exploring new algorithms. There's, constant research going into building out new and more effective ways of solving these problems. And, we're going to be looking at those new algorithms as they come out and going through this process kind of all over again, building the model in with the new algorithm and testing its performance against our existing one. A couple of things that we're working on right now. I think one of the weaknesses in our data was how we were tracking velocity. So we've been working with our engineering team to rebuild and reinvent our velocity tracking, and we're starting to launch that now and training our data. And then we're also looking to explore using machine learning for other aspects of fraud prevention. So we know that it does a great job in making these fraud, not fraud decisions, but we want to look at how we can use machine learning to surface trends or MOs that we haven't trained against, right? So right now it's a very manual process of going in and looking at the data, seeing where we're seeing abnormalities in the data and vetting those out. There's unsupervised algorithms that might be able to help us with that. So just going in and surfacing anomalies, surfacing trends, and hopefully allowing us to detect and stay in front of MOs. So that's the bulk of the presentation here. I'm going to hand it back over to Ajay. I hope that was helpful for everybody.
Thanks, Dustin and Yue. That was really exciting to hearing about your progression through kind of building a model, and it's great to see the results you're seeing using machine learning as you kind of scale your business. Just to kind of wrap things up, I want to talk a little bit about using our data in your machine learning model. Our approach typically is that we have a very quantitative and consultative way of proving that our data can provide some form of lift in your workflow, which, like I said before, we typically measure using AUC or kind of a movement in the in kind of precision, or one of those metrics that Yue spoke about. So we have we kind of understand that model building is cumbersome, and there are always more models to build and data scientists available. So we also help with a lot of the heavy lifting in terms of exploratory correlation work, information value analysis. And for some customers, we often will build a very simple proof of concept using our machine learning stack. So happy to work with anybody who's interested on those fronts. I also want to call out that we have this pretty cool machine learning guide available on our website. The link is on the right side of the slide. It's really a condensation of all our learnings in the last couple of years about how to integrate our data and how to think about just building a machine learning model really quickly and seeing the results that kind of Dustin and kind of Yue spoke about. We're going to jump into question Q&A now. Just a couple of quick things to shout out. A bunch of links here if you want to dive a little more into our products or machine learning at Whitepages. For those of you in Seattle or kind of in the Pacific Northwest, We have a meetup in a couple of weeks on October 11th where a number of data scientists, both from within Whitepages as well as our customers in the Seattle area, are all going to kind of talk about some of the work we have done to do real-time predictions using the XGBoost kind of modeling stack. So really interesting topic if you're in the area. And if this kind of work interests you and you're a product manager or data scientist, we're hiring for a growing team. So feel free to kind of email me, and I'd love to talk a little more about the work we're doing here and some of the problems we're trying to solve. With that, we've got a lot of questions, and I'm going to try to at least answer some of them with Dustin and Yiwei's help. So maybe to get things going, got a question we thought was very interesting, which is from Narahara, which is, did you decide to use supervised machine learning? And can you talk a little bit about how do you decide what machine learning model to use?
So, can you repeat the first part of that question?
Did you decide to use supervised machine learning, and how do you decide what machine learning model to use?
Yeah, I can start, and I'll hand it over to Yiwei to get into a bit of the details there. Yes, we are using a supervised learning model. It's a tree-based model, and why we went that road is one, just because of my experience in the industry and seeing that it works and it's effective. The particular algorithm is a extreme boosted trees model. I'll let Yiwei speak a little bit of why he landed on that particular algorithm.
So actually, just like in the slides, you also mentioned that for Whitepages Pro, it like largely used XGBoost. XGBoost has proven to be super effective, especially in the fraud prevention area, and even in like Kaggle competition, if you're familiar with it, it's like super effective. And for the question about like why we choose supervised learning model, I mean, you have the mature and huge amount of response data, which is your decision on whether it's a good booking or not. It's pretty normal to choose supervised learning, right? For unsupervised learning, there are definitely works in the industry on using unsupervised learning against like fraud. But I would say more of the research are on more about anomaly detection instead of like a general trend of fraud. And that's my understanding on that part.
Great. Thanks for that. Another really kind of interesting group of questions. I'll try to kind of condense into one question from Theophilus and Fangyan, which is, how do you guys expose kind of the black box in like a machine learning model? And I think that's related to what exactly is the LIME explanation? What is driving that analysis, and how do you calculate the so-called feature importance?
Sure. So I think to that first part, and I saw the question in the box there. So what do we expose to our agents? We've created an in-house investigation tool as well, and have really built that out to make sure that we're highlighting and showing agents what's important to making the correct decision in that booking. In some cases, we are emphasizing points in that data that the model is telling us. For example, if the Whitepages Pro score is high, we want them to be checking that data to make sure that there's to go in and validate the address or something like that. So does it introduce bias in their decision making? Perhaps somewhat, but I think we've also seen that there's value in doing that and just making sure that they're addressing the right points in the investigation to make the right decision. We do also expose the LIME decision to agents, but I don't think it's used as part of their investigation process too terribly often. We're more using it in our A/B testing to evaluate why the model is making the decision that it is. I'll let Yiwei talk a little bit more about what LIME is and how it works.
So I won't really go too detailed about that because that'll be too technical. But yeah, you mentioned about like how you get like calculate the feature importance. So you do know that in most common scenario you can accept whole models performance and features importance on certain features, but that's for the whole model. That's not on the transaction level. And for the whole model, you can definitely use your entropy and information gain from the tree structure algorithm to get that. But in order to get the explanation on a transaction level, there used to be no traditional way. But recently, there are research papers more on a topic about the Lime, and I definitely urge you to Google that. The full name is Local Interpretable Model Agnostic Explanations, and it's a fantastic tool. Although it may not give you like Dusic Machine, suddenly you get all the things out of your model, but it definitely gives you a lot more transparency to your model. And even it's able to be applied to neural networks. So definitely check it out.
Awesome. I wanted to just try to answer at least a couple more questions. So Dustin and Yue, AJ asked, do you err on the side of preferring more false negatives or more false positives, and how do you kind of balance those metrics?
Yeah, it's a great question, and I think it's really more of a business question. What's right for your organization? As I mentioned, in our space, the cost of being wrong is extremely high. Right? Again, we have fairly low margins and extremely high risk when we are wrong on a fraud decision, as we're getting all of that back to us. So we might have sell a $2,000 ticket where we're making $40. But if that's fraud, we get the entire $2,000 back. So I would say in our space, we're erring a bit more on the cautious side. We're putting more in front of manual review, and we're taking less risk just because of that inherent risk in the business. Now, for digital gaming or different industries, you're going to have different places to set those metrics and review rates. It really just depends on what's right for your business and what amount of risk you're willing to take, and how much friction you're willing to apply in the process for the customer, if that makes sense.
I may add something. So definitely your business goal will be largely different from industry to industry. But on the other hand, from your model building side, you also, again, you want to choose your quantified matrix that in favor of your KPI. What we mentioned, AUC, it's a great tool, but it's, again, more generalized. Like if you want something more specific, for example, more focus on your false positive or false negative, you can go choose other metrics you have. Besides AUC, you have F1 score, you have all kinds of metrics, and you can even be creative. You do know that you can create a matrix yourself and use that in your cost functions to optimize your model. It's all your choice if you have a good data scientist. So be creative.
Awesome. One last question, guys. How many Whitepages Pro variables did you include in your model? What were the names of those Whitepages Pro variables? You spoke about the kind of identity check score. And I'll add one more kind of related question was, what was your approach to figuring out which Whitepages Pro variables to include and which kind of to leave on the kind of the cutting floor?
So I'll first answer the second part of the question, which to include, right? First is definitely your business understanding of your features, like for not only Whitepages Pro feature, but for all of your features you have on hand. I mean, not in all situations you're going to just put all your features into the model and say, okay, let you figure it out. No. First, you need to assess your features, whether it makes sense for your model to include it, whether it will bring benefit, whether it will bring usually mostly nothing, or even bring harm to your model. You can, as a business person in the first place, even for data scientists, you need to have business acumen within that to understand, do you want to include that in your model? And second, again, definitely you can use models assessment on whether the feature is important or not. Go check out the feature importance, test whether you pick one or you drop one will lead to the increase in model's performance. There are a lot of like traditional ways in assessing the model's importance and like feature selection. So just that's also pretty important when you build a model. And what's the first part of the question?
Just what variables we're using with Whitepages Pro.
Oh,
I think we've got several. I don't know that we want to list them all out here,
yeah.
but yeah.
I would say most, definitely not all, but most of the variables. I don't know if I want to say it here or not.
Probably how many variables are we using?
Well, first bear in mind that some of the variables are not applicable to our business. For example, shipping information. There are a lot of like shipping info match provided by Whitepages Pro, but clearly we are a digital only business. We don't have those kind of information. But after taking all those out, I would say 15 around.
Yeah. Yeah, so we're using a lot of their matching data, basically, everything that we've found value through and using it in our manual investigation process. And going back to Yuwei's point and just how we selected the variables, it was a combination of using the feature importance diagnostics as well as just business knowledge, because we've had issues building models in the past where the model is telling us that there's a strong relationship between these two variables, but it doesn't make sense from a business standpoint or an operational standpoint, and it just happens to be an anomaly in the data. And you don't want to build a model off of these relationships that don't have an explanation behind them, because they could change tomorrow and it proves up the accuracy of the model. So it's a bit of a combination there.
I have one point to add. Although it's like what we use from purely Whitepages Pro is like roughly 15, I would say. But think about it, you are going to integrate those data with your existing data on hand, and that can create tons of new possibility. And just be creative. You can do actually a lot of things. Not only 15, you can expand that to, I don't know, like 40, 50.
Yeah.
By using that combined with the data we have on hand.
Yeah. For example, I mean, we could use the identity check score in combination with other data that we have in-house to create new variables that might be even more powerful than the identity check score alone.
Awesome. We'd love to keep going, but I think we're unfortunately out of time. So first of all, thanks Dustin and Yuwei for putting this content together and kind of spending some of your time walking through folks on the webinar through your thought process and thinking about building a machine learning model for fraud. Definitely a very top of mind item in most companies today. So I really enjoyed collectively talking about the work we're doing. Thank you for joining from all over the world. And like I said, a number of resources over here for you to both dive into what we do as well as reach out to us. So thanks once again, and enjoyed having all of you on this webinar.
Thanks for having us, Ajay. Thanks, everybody.